Quantum superposition sounds like two really large and confusing words. However, with an open mind, this fundamental principle of quantum physics can be simplified and be understood by almost anybody. Now, quantum superposition states that an object can be in two states of being at the exact same time. Meaning something classified as matter can be in two states of being at the same time. In the case of an electron, it can be a solid or a wave, depending what its situation is. Now, the most commonly used example of quantum superposition is Schrödinger's cat. In this theoretical experiment, Austrian physicist Erwin Schrödinger put a cat inside a box. Inside the box, there's a device that is able to release a poisonous gas that will kill the cat instantly if it detects radioactivity. There's also a radioactive bit of metal in there that may or may not release its radioactive particle. Does the cat survive? Well, we don't know until we actually look inside the box, in which case superposition ends and it takes either the form of being alive or dead, depending on what's happened. Now, let's take this down to the next level. Let's say so long as we aren't observing, the cat is not only alive and dead at the same time, but it's at all points of time and space at the same time. What I mean by this is that the cat could be in the Jurassic era or 20 years in the future for all we know. It may not even exist. In which case, superposition is still in effect until we observe what's inside the box. Now, you probably still are confused about all this, partially because you have nothing to compare it to from your day-to-day experience. But there is something I can guarantee you've done that does relate. And that'd be sleep. That's right, sleep. I can say sleep is an analogy of quantum superposition because when you go to sleep, you're no longer observing your surroundings, meaning you could be, like the cat in the Jurassic era, or 20 years in the future. But once you enter deep sleep, and no longer aware of your body, and is dreamless, you become like Schrödinger's cat, meaning you could be alive or dead at the same time. Does this mean you're actually alive and dead? No. At the micro subatomic level, technically, yes. Once we bring it onto our large scale realm of ourselves, no. Now, let's take this again to another experiment that may seem a bit more physical to you. In British physicist Thomas Young's double-slit experiment, he took an electron launcher and started shooting electrons through a single sheet of metal with two slits through it. So long as he wasn't observing the path of the electron, it was generating wave interference, which is where two waves collide to form this image. Anywhere where there's a bolded spot is where waves met, and anywhere it's black is where waves cancelled. Now, this confused Young, so he started setting up things to measure and to observe the path of the electron, in which case it formed this, which is what he was expecting to see when he studied the experiment. Why are these two things so different? The reason being is because of quantum superposition, meaning, while he wasn't observing the path of the electron, it was taken at all points at the same time, and was actually showing it. But once he had started observing it, it became what became the two slits. And all because someone observed it. That's how picky quantum superposition is. Now, let's relate double slit to sleep. Now, what we're gonna do is that in this hypothetical thing, while you're asleep, you're essentially like the electron in all points of being at the same time, meaning your graph looks like this. Now, once you wake up and start observing your surroundings, your graph again becomes more like like matter. Well, I hope this simplified quantum superposition and made you see that the really weird world of quantum physics is not at all as confusing as it may seem.